Good morning, or good afternoon, or good evening to everyone, depending on where you're connecting in from today. Thank you for taking time out of your busy day to come attend a Crank Software and Renaissance webinar. Of course, today we're talking about how you can future-proof your embedded products to whether it's changes in hardware or changes in design that will naturally occur over the life cycle of that product. Before we jump into things, I just want to let you know that this will be recorded. So that way, if you need to drop off or maybe you have a colleague that you think will benefit from this webinar, you can share that with them after the fact and they'll be able to get access to it on demand. Because we are streaming over the internet, if you do run into any audio issues, definitely after you've checked your settings, try refreshing the window. We find that about 8 or 9 times out of 10, that typically resolves the kind of packet losses that may be occurring. Also, we will address any of your questions that you may have. You can input that into the Q&A window that you should see on your screen, and we'll address those at the end of the session. Also, if you haven't already, feel free to follow either Renaissance or Crank Software. I know Crank Software, we're active across all the main kind of social media platforms, whether it's Facebook, LinkedIn, and of course Twitter. If you want to interact with this, please use the hashtag Crank Storyboard or hashtag GUI Development. We track those all the time. Today, we're lucky to have with us TJ Mueller from Renaissance. He is the Product Marketing and Business Development Manager at Renaissance. We also have Nick Schultz, who is a Field Applications Engineer here at Crank Software. And last but not least, myself, Scott Snyder, I am the Product Marketing Manager for Crank Software. So what are we going to be talking about? Well, first of all, we're going to dive into all things Renaissance. We'll talk about all the great things that about the RZG line. Next, we'll kind of talk about, Crank Software and Storyboard and how it can really help your embedded products be more fluid to those design changes. And more specifically, how our rapid design and iteration technology really removes the barriers that can often disrupt the development cycles that you may experience when creating your embedded products. Then, like I said, we'll get into a live demo and then answer your questions. So to kick things off, I'm going to hand things over to TJ.
Okay, sounds good. All right, greetings. And as Scott said, I'm TJ Mueller and I'm responsible for product marketing and business development at Renesas. And I specifically handle the RZG series of 64-bit microprocessors. So today we're going to talk about the G2L series, and there's three members in that product line, and all these are targeted at basically entry-level HMI applications. The G2L is the leader of the family, if you will, and it has the most capability for, again, it's for human-machine interface applications with video and camera and graphics and everything. The next one down is the G2LC, which is entry-level HMI with a camera and not as much video and graphics. And then finally we have the G2UL, which is a little more bare bones, if you will, for simpler HMI, and then IoT gateways and simple cameras and network audio. Okay. And to kind of like frame things a bit, we have this is the RZG2 NPU product lineup. We currently have the RZG2H series, if you will, in production, and these go up to up to eight cores total with the G2H. But today we're talking about the newly introduced products, the G2L series, and these are targeted again at the more the industrial displays and HMI type applications. We have these devices have dual core A55s and then a subcore M33 subcore for the like an MCU to do the housekeeping tasks. And we have the graphic processing unit, and the G2L has the codec, the H.264 HD codec. So that's the product lineup. So a couple of the value proposition, if you will, for the G2L. There's three basic pillars here: scalability and compatibility, then reliability, and then compact design, so you can get these things into small HMI type of applications. So in terms of scalability, we have a lot of commonality there. We have the software is compatible between all three products: the L, the LC, and the UL. The LC and the UL also have a pin compatible version, and there's one of the UL that's not pin compatible for additional things, but you can try that. And then our evaluation boards, our EVKs, and I'll go into that a little more later. They're compatible between the three products as well. So we have a carrier board, and then we plug in other SOM modules for that compatibility. So very compatible within this family. In terms of reliability and quality and security, we have a long-term Linux maintenance program, CIP Linux, and we support it for 10 years. So it's very long-term in terms of that. So the code is very stable, if you will. We have ECC throughout, especially on our memory, the DRAM interfaces, if you will. And then finally, we have the security. We have the secure. We have the trust zone, ARM trust zone, and the secure boot. And then finally, the compact design. We have the package sizes vary from 13 millimeter square up to 21 millimeter square, depending on the product. I'll go into that a little more detail later, but good compatibility there. Okay, so some of the integrated functions that are applicable to industrial human-machine interface applications. You can see here on the left, on the L and the LC are compared. Both have the dual Cortex A55 cores, which are the most, the leading edge of these ARM cores. The memory that we use is DDR3L or DDR4. The L has the H.264 codec for 4K video codec. Both have the Mali GPU graphics processing unit. Interfaces for camera are MIPI CSI, and then the L also supports parallel. And then for comms, we have gigabit Ethernet, and we also have a legacy, CAN interface common in the automotive use, but lots of HMI applications use that. And also the L has a 12-bit ADC that helps with sensors, acquiring sensors that are connected to the MPU. And moving on to the next slide, there's a lot of built-in peripherals and a specific a PIMIC that's dedicated to this device. So we've integrated the ADC and the MCU, the subcore, and so we've integrated those into the G2L. The DRAM is off chip, of course. And instead of having discrete power, we developed a PIMIC, a power management IC, specifically for the G2L family. So it was developed specifically for this, and it helps in terms of board space and cost and everything, reliability and all that. Okay, this is the reference board that I was talking about for the G2L family. As you can see, there's the bigger board is the carrier board, and on it is mounted the SOM module board. So we use the SMARC 2.1 standard for this, and we can accommodate the G2L the LC, and the UL, all with the same hardware. And then we just list all the peripherals. So the carrier board brings out all the peripherals, all the interfaces, so the customer can use this to test everything. Couple of use cases here that I'll go over. If on the for the various for this one's for the for HMI equipment and industrial displays, commercial cookware. So for the display out, we have basically MIPI DSI, and the touch panel uses USB. Recording media is the SD card. The boot is eMMC, and then we have all the networking, the wired networking, Ethernet, if you will, and comms ports and all that. So it had lots of interfaces, which is really the key for this product line. We have a lot of processing power, and then we have interfaces. We have a lot of like peripherals / interfaces. This is like a block diagram of what I was previously talking about. Some people prefer this, or you can look at it later as well. But you can see that we have everything from RS2, 422, 232, and all that, and then we have the LCD touch panel operation, and then interfaces via comms ports. For the next one, the next use case is a intercom / door phone. These are quite popular these days. The device we can record the video input from the camera and display it on the LCD panel. So there's a graphical interface support, and it works with smartphones, of course, too. So so the camera interface is either digital or analog, and display out is the MIPI DSI, and then all the other interfaces that I discussed previously. And then I have the block diagram for this as well. So you can see the camera and the audio in. And then on the out, we have the touch panel, which is HD up to 60 frames per second, audio out and all that, and then we have interfaces to Wi-Fi and various comms again. And I mentioned like the PIVC that we have there for the PIVC is off chip, of course. We have the PIVC and clocks to support these as well. I think that's my last slide. I guess I'll turn it back to you, Scott.
Perfect. Thank you, TJ. Moving right along. I'm going to jump into just a high-level overview of who Crank Software is, and then definitely jump into introducing Storyboard to you. So if we stop and we think about it, it wasn't actually that long ago where the displays of embedded products were small screens that maybe had a grayscale or two-tone displays. However, with smartphones and tablets and smartwatches and other personal devices now commonplace, our expectations of what a great user experience has really grown tremendously, really, with sophisticated high-end experiences available in our pocket. Consumers today, as well as within our professional life, we have are demanding or expecting that same graphical user interface across everything and anything they buy. It definitely presents a challenge for embedded developers, as these high UX benchmarks are what are being the product is being measured against. So not only do we ensure that our applications can compile, run, and perform on microcontrollers or microprocessors, we also need to now guarantee this rich, vivid UX experience that will win and retain customers within our market space. So regardless of the different form factors that products now come in, depending as to how small they are or how much limited real estate may be on the screen or how much power they actually provide, they truly expect that it's going to perform snappy, and it's going to provide this smartphone-like experience. More importantly, though, is that evolutions in technology no longer mean which hardware is the best fit for the device, but how you can incorporate those hardware technology changes into that user experience. Also, it goes without saying is that, as we have more work put on us, the deadlines seem to get much shorter. So trying to get to market on time, get to market ahead of schedule when there's so many options available to us. So whether it's hardware choices and OS choices and form factors, that definitely, if you can have something that can help you get there ahead of schedule or be on schedule, can really make your life easier. And that, of course, is where Storyboard comes into play. So if you've never heard of Crank software or Storyboard before this presentation, I can guarantee that there's a good chance that at some point in time, you've interacted with a product whose HMI or GUI interface was built using our embedded GUI development tool, Storyboard. So Crank Software is a software and services company that's currently headquartered in Ottawa, Ontario. It was founded back in 2007 from a leadership team that had an extensive background in embedded software systems and graphics. So they set out really to kind of, build a product that could easily make the embedded development GUI process that's much more simpler, and it's been used in products around the globe, both inside small organizations as well as Fortune 500 companies. Not only have we received numerous awards for our software, but our customers that have built products using Storyboard have been recognized as well. And currently right now we have a large, extensive partner and distributor ecosystem, as well as millions of devices that are active in the field today, really helping shape the next generation of embedded user interfaces. So powerfully simple yet sophisticated is what we hear quite often from our customers. They tell us that it's easy to use interface really enables them to quickly create UIs more easily and more efficiently, enabling them to get to market on time or even ahead of schedule. And this is done by Storyboard's unique architecture. So we decoupled the front-end UI from the back-end logic. It really makes it easier for you to get started earlier on the UI development process. It also makes it more friendly to embrace design changes or iterations that naturally occur, and also helps reduce the complexity of really developing GUI solutions for or in an ever-evolving embedded hardware market. So really, how does it help achieve this? Well, it does it in 3 different ways, and let's dive into that. So all before the final hardware decisions have even been made, the UI development can begin within familiar UI design tools such as Photoshop or Sketch, and when ready, they can be easily imported into the Storyboard tool, really creating the building blocks of the UI. From there, the UIs can be brought to life using Storyboard's integrated animation tools, really allowing you to create, edit, and review animations all directly within a single tool. From there, critical UI flow and usability testing can be performed using its integrated prototype and simulation functionality, all again without actually requiring any final hardware decisions to be made or having to deploy it to the actual hardware itself. Once development begins, designers and developers can easily fine-tune the GUI application based upon internal feedback or external feedback, and really make those changes to the product without impacting past development efforts, or even worse, causing a complete teardown of code. So these introduction of design changes can be done within basically going back to maybe the design tools of Photoshop or Sketch making the changes. Maybe it's changing colors, maybe it's moving the location of buttons, changing the size of the buttons, the text on the buttons, and then basically re-importing those design files back into Storyboard, all without having to create an entirely new application or overriding prior development. So what really kind of sets it apart from other tools is we have a unique graphical compare and merge tool that really allows you to remain in control of those iterations. So what it does is it compares what was there as to what is newly being imported. It allows you to choose which changed content you wish to accept and to deploy into the application before committing changes to the final design, really allowing for a more efficient and collaborative experience to creating GUI applications, and particularly when you think about you have multiple people that are involved in the overall development process. Also, we have within it a set of tools and actions that really allow you to obtain actionable insight that to really assist with the development decisions in the UI being developed. Through its performance and optimization tools, you can monitor resources directly within Storyboard so that you know with confidence that your UI or your GUI application is going to be optimized for the target hardware. And then, of course, even with all the vast choices of hardware that you can choose from Renesas, and of course, the operating system combinations that you have, it's highly likely that Storyboard GUI applications can run on it. And this is because Storyboard was created to be platform agnostic. So that way, really de-risking the embedded development projects by introducing a framework that easily supports technology and design changes at any point in the development cycle. And this is done through the unique creation of our runtime engines. So instead of you having to go and really kind of fine tune how the graphics are going to be rendered on the hardware and OS yourself, and then compiling it, testing it, compiling it, testing it, our R&D team have done that for you. So we work closely with our partners such as Renesas and to make sure that we can optimize the GUI application for you. So that way, if you want to deploy on, say, the RZG2E or the RZG2M, or when the L comes out, all you have to do is marry up that specific runtime with your application, and that's as all it takes to make sure that it runs on that hardware OS combination. Also, what it really allows you for is this UI flexibility. So it allows you from scalability for moving up from optimized low power MCU hardware to maybe more powerful MPU hardware. It provides you that portability so you can really adapt to technology changes. So say, for example, you were going through the creating for the RG2EM, say, and then you wanted to go to the L when it comes out, like what TJ was talking about. You can easily kind of take your application and switch it over to that. So you can make those changes to that technology stack, whether it's hardware or OS at any time, to really take advantage of maybe any specific board features or unique functionalities that are being introduced. And then, of course, you have that reusability side of things, which allows you to reuse your existing GUI applications that you've created across different product lines for maybe you have a high-end to low-end kind of product range. You want to have that consistent brand look, touch, and feel across the other products. So speaking of which, I just wanted to kind of quickly discuss kind of 3 examples of how real-life customers were able to continually update their products, keeping them fresh and resilient to the changing market and their customer needs. So the goal of the first customer was to introduce their next-gen fountain dispenser based upon new technology and consumer feedback that they had into the field. However, the challenge that they faced was that they were looking to do this also for their existing Gen 1 series that they had out in the field already, and they wanted to do without disrupting their Gen 1 series in the field, which was originally, I believe, first introduced around 2009, 2010. Unfortunately, they were not able to do this with their existing HMI development tool they were using, so they turned to Crank software and Storyboard. And working closely with them, we were able to create an exceptional user experience that worked across the different hardware platforms that they had in their different machines, and really extend the life of their existing products that they had out there in the field already by introducing this fresh, new, and improved user experience to it. The next customer was looking to make a giant leap forward in the evolution of luxury motorhome driving experience by introducing HMI controls that they could customize for each customer. However, they had not yet decided on the final hardware that they would use, and this lack of hardware decision was in going to potentially delay the entire project. So they came to Crank Software and they used Storyboard to help them keep on track by being able to start the development of their HMI without actually having those hardware decisions being made. So doing so, they were able to get to market in 6 months ahead of schedule, having a product that they could go back to at any point in time and make changes to for their customers, so that way they could customize the colors or the layout of the original application that they created much more quickly and more efficiently. And then finally, we have a customer that also creates cycling products that found their original product was at a crossroads, since smartphones were really changing customer or consumer expectations of what portable devices could actually do or provide. Their goal was to really regain the market share they once kind of monopolized by modernizing their dash cycling computer significantly by enhancing its functionality and, of course, its user experience it offered. However, there were several challenges they experienced. First, the product required a significant technology update, both when it came to the hardware they were going to be using from the original one, as well as a UI UX. It needed to integrate with their existing assets they had, like, for example, proprietary mapping and such, into their new user interface so that it appeared completely seamless to the consumer. And also, they required the ability to accommodate different user needs with different size products. So ultimately, they leveraged Storyboard's rapid design and iteration technology to really kind of go in, kind of make an initial design, test it, and refine it until they had an experience that they were satisfied with. And they did it with all about not worrying about destroying the previous work. And since the application created using Storyboard was portable, they were able to accommodate different consumer preferences, different screen sizes and such, by using the same application across the different products. So Storyboard was designed to really kind of remove the barriers and issues that are typically associated with GUI design development. It's purpose-built for collaboration around the UX. So it's designed specifically to help developers and designers work together and iterate with ease, all in the quest of developing the most optimal end user experience. Its low code to no code kind of GUI development framework really lowers the barrier to entry for software development. Plus, like I said, it has this distinct separation of design and code environments between the front end and the back end. Really enables developers and designers to update and test the app at the same time in parallel without disrupting or destroying the work being done. Also, like I said, its rapid design, iteration, and re-import technology really allows you to kind of leverage design tools that many designers use when it comes to building UIs for today's products, and allows you to really kind of to leverage those files from the initial file deployment as well as any updates all within the tool, without kind of, with all actions or events that were previously established being disrupted or lost. And then, of course, its unique graphical compare tool really, like I said, allows you to remain in control of which changed content you wish to accept and deploy before committing those changes to the final design. Its embedded animation tool really allows you to track all the changes made to the application, automatically create new animations, reflecting the activity between the start and end points of those changed items. So allowing you to say, when a screen changes, play the animation from this point, or start it from this end point, or go fully in reverse. And then last but not least, it is platform and OS independent. So the runtimes that have been created and optimized for the hardware really enable the storyboard developed GUIs to be deployed on different hardware simply by using that appropriate runtime, really providing your project scalability, portability, reusability, but really de-risking your overall development process. And so with that being said, I'm going to hand things over to Nick, who is actually going to take you through a live demo of Storyboard.
Perfect. Well, thank you very much, Scott. And the intro from the Renesas side from TJ was fantastic as well. And really looking forward to walking you guys through a quick demo of Storyboard so you can get a great idea of how we make GUI development easier. And what I'm going to do is actually I'm going to switch over and show you something in Photoshop quickly before we jump into Storyboard. And by no means am I looking to teach graphic design. That's certainly not my background, but it's always nice to see the before and after effects of where a design and an application starts. So here we have a home automation application. You can see thinking of sort of a multi-purpose wall panel, something like that, where these things are getting a little bit more common with more integrated IoT systems. So we've got thermostat controls, weather updates, settings, localization, brightness, Celsius Fahrenheit conversions, things like that. Some voice control for all of the voice assistant integration that's coming standard these days, and then finally some security. And really, all of this is to say that when you're building a bespoke product, the interface really begins and ultimately is shaped by what happens in design. So a big part of what we do and what Scott alluded to is that we really want to support designers in terms of giving them the ability to design high fidelity content that you can bring into Storyboard directly and start implementing interactions, animations, behaviors, stuff like that right out of the gate. So all that being said, you can see here we have a few screens. There is a naming convention that takes place in the design file that we follow and we use to parse and lay out the content, and it maps to the Storyboard hierarchy. So just at a very quick high level, content is going to be broken up into what we call screens, and you can see the representation here in terms of what Photoshop calls an artboard, but we also support sketch imports as well, so the exact same paradigms apply. Each screen is then built up of one-to-many layers. Layers are the groupings of unique or like content. So you can think of this thermostat content as being unique to a screen, temperature update controls, and then menu content also being a logical grouping, but something that could be shared across other screens. So these names will determine how content is used, and we're very big on designing something once, reusing it in multiple places if possible. So the content like scrolling menu layers that's currently not visible, and the menu content is all shared and reused, same with the background layer. So all that being said, I just wanted to show this off first. So when we do the import, it's going to look exactly as what you see here, and that's part of the magic of what we provide. So I'll go and close this down. And from here, you can see the Storyboard workspace. And if you've never played with Storyboard before, never heard of it, this is what you'll be greeted after installation. Links to our tutorials, documentation, support channels, and some helpful getting started videos and guides are all available for you to play with. Close this down. And you can see here that we're built on top of the Eclipse framework, which is if you've done any sort of software development, something you're likely very familiar with, but it also means that you can run Storyboard anywhere you can run Eclipse. So my day-to-day, I dual boot between Windows and Linux and run Storyboard on my Ubuntu distribution. You can also run it on Mac. and all the collaboration tools for revision control integration that are available with Eclipse are all something that we support. So whether you're using SVN, Git, or some of the the web-based workflows with Bitbucket, GitLab type accounts, those are all things that you can do and collaborate across multiple members of teams. And to kick things off, this is where we're going to import a new project from Photoshop content. You can see there's an option here on the application model view on the left. There's also the ability to create a project from scratch or even import some of our samples. So after the fact, I'd encourage you to download a free trial from our website and also import some of the samples. They're great ways to showcase how to build up content and get familiar with the tool. So new project from Photoshop content. Links are also available in the toolbar there, some buttons. And then I will simply browse to this location. From here, we'll go down. I have my thermostat demo available here. And we're reading the content, and I'm going to leave all the options set as default. Most of these are just sort of minor presentation options. If you want to wrap text, that expands past the zone in Photoshop, you can choose to do that. If you have a design going and you're getting content piecemeal from a design team, you can import into existing projects. So you can bring content in as it's available. So again, a lot of flexibility on your workflow and just supporting the natural iteration that occurs while you're building a project. So I will hit finish. Tools going through, it's reading the Photoshop file, it's slicing up all the images, it's getting information from the fonts, all of that. And you can see here we have the content laid out as we saw it. We are ordering our screens alphabetically. So in the design file, that's where we saw the thermostat screen set to be the first one, but that's really the only difference. If we expand this content, you can see here we also have representations of those layers that I talked about. So the menu layer, again, being there and made up of our sub controls and buttons and elements that we're going to play with as we build up this sample. First thing that I will do though is I'm going to go ahead, I'm going to set this to be my default screen, so my start screen over here on the right in the properties panel. And I'm going to hit simulate. And you're probably wondering why, because I actually haven't done anything yet. But one thing I want to highlight is that when running your application, this simulator, and I use the term simulator loosely because it's actually the core rendering engine that Storyboard offers, just built against my desktop machine. So it's a Windows build that leverages OpenGL. The same thing applies to my x86 Linux desktop with GL or Mac environments. And the equivalent runtime is built and deployed on the Renesas hardware that I'm going to be deploying to shortly. So when you're simulating, you get the same thing that's built into Storyboard on your desktop than what you'll see on the embedded hardware. So again, you've got a lot of power and a lot of confidence in what you're developing and testing. You may also notice I have these button effects already built in. There are some naming conventions in the Photoshop file that allow you to bake those actions in, and our tool will go ahead and hook up that behavior for you. So, if you think of a button, it's generally quite simple from a UI paradigm. There's usually an effect that happens on press, same thing on release, and then sometimes if you click and drag out, that outbound event will return the content as well. So all of that was hooked up for us. If I look at that content on the screen, you can see here with our button, I already have press, release, outbound, and what's happening is something called a data change, where we're simply changing the path of the image on the fly to give you that effect. So pretty simple, but again, a lot of nice things that you can get and will reduce your boilerplate work. So the first thing that I always like to do when I jump into an application is wire up the screens and the navigation. And this sort of brings up what our event model is, how we interact with content, and how we add behavior. If you see here, you can see we have these elements on screen that are contained in layers. So these are controls. They contain render extensions, which is simply, something that is rendered on the display. So text, images, filled content, 3D assets, you name it, you can mix and match all of these to create the effects that you're looking for. But these buttons along the bottom are the first and easy step to creating this behavior. So if I right click on the button, I'll add an action, and this is where we can start hooking up this interactivity. And everything that happens in Storyboard is event driven. And what that means is that you need an event to start some form of behavior. Events, an event-driven system is certainly not unique to Storyboard, but very important in the context of embedded development, because we don't do anything unless there's an event to trigger something. So if you were to compare us to what you might see in a game engine or other rendering technologies that aren't event-driven, they're going to be running on a tick, always trying to hit a certain frame rate or maybe even an uncapped rate. And that's great for what they're trying to do, but on systems that have very limited resources, think of some of the smaller MCU systems that Renesas has available to them, where maybe it's a single M core with a couple hundred megahertz, as opposed to the powerful MPUs that we have today. That's very important, or especially in battery-powered systems as well. Anything you can do to reduce CPU cycles is important. So all that to say, without an event, we're not doing anything, and the display content, the display won't be updated. So to start adding interaction, this is where we pick an event. And in this case, you can see all the built-in events that we have. I'm going to select a touch event, and then the action being, what we want to do, and plenty of built-in options as well. And this is where I'm going to select a screen transition, and I'm going to do a path transition. Going to pick my destination screen, weather, and you can change some options here. So I can do frame rate to 60. This is a powerful piece of hardware with graphics acceleration. I can choose a direction, so move to the right and hit finish. And you can see there we now have that binding, the event action, and the parameters on the right in the properties panel. And then I can just copy that, paste it onto the weather control. And this is where, the nice thing is now I simply need to change the destination screen. So if I go through, select, weather, I did that one wrong. Update this one for thermostat. There we go. And then finally, same thing applies for the settings screen. And in this case, I'm going to pick one of the settings screens. I'll pick security in this case, and I will save that and simulate again. So again, a couple clicks, really nothing overly complicated, but now I have that nice animated transition, nice fluid 60 frames a second. And the other interesting thing that you might have noticed is I only hooked up those bindings on the controls on the thermostat screen. But because this menu layer is shared across each screen, all of those bindings propagate. So again, it's doing something once and propagating the effects. And you can see this in action, and I'll quickly actually show you these buttons were already bound up for us too in the design file, so ready to add behavior. But if I were to make a change to, say, the crank logo in the top corner, you can see that propagates on every screen that has that layer instance. So we've got our transitions hooked up. The next thing that is always important and very crucial to high quality HMI applications today is animation. And animation is something that gives that little extra polish and sort of experience and intangible feedback to the user when evaluating your product. And they can be quite subtle or very complex, but having that there can take a nice or a good UI and make it great. So we make that easy, and we have an animation timeline built into our tool where you can manually create the animation, start picking the properties, So more or less any option that might show up in these properties panel that you want to animate. But we can also shortcut that and enable an animation record feature. So in this case, I click the button in the top right corner. We have this red border to signify that we're recording changes. And this is where I can make changes to content and use that to bootstrap my animation. Some of you may notice when looking at this in Photoshop, or even when expanding some of the layers here, we have this scrolling menu layer. And it's filled with content that right now is actually tucked off screen. If I select all of those controls, you can see their X position is -290. And this is the content for this sort of context menu in the top left here. So I'll go ahead and set that X position to 0. You can see it popped out there. And then I will hit the toggle recording button again, and we're going to close off that animation. Give it a name, menu open, give it a frame rate, again 60, take some absolute values since it's a little bit more obvious from the start and end positions, but you could use delta values if you wanted, and we'll leave the iteration at 1. You can see here after I hit OK, everything on the screen reset. And this is important because you may not want to change the layout of your content, but you want to be able to move stuff around to fine tune where it's going to end up. And the other thing that I didn't show, but in multi-stage or multi-step animations, you could also take snapshots with this button. So maybe the first thing is your content slides out. Maybe you want to fade in a blocking layer in the background or something like that. You can go ahead and set that up with the record feature as well. But now that we have an animation, you can see all the steps here in the timeline. The tool does a best guess where it's going to default the duration of steps that aren't direct changes to 500 milliseconds. I'm going to pick some default easing curves where you can see there it's a linear easing curve, but you could change that if you wanted. And you also have the ability to preview that to see what it looks like. And this is really important because you are probably not going to get the animation right on the first go around. And I can say from my past experience when working on projects that, I was working with a design team, and even before joining Crank and working with Storyboard, I would be lucky if I was given a video of what the animation should look like. And then I was given all the assets and a loose description of what it had to be. So coding that up and building it in code, it took a lot of iteration, a lot of playing around, recompilation, deploying to hardware, sort of very time-consuming turnaround to get that just right feeling. But now with the preview, I can step through this and see what it looks and feels like and get feedback on it right away. And to that point, I think we can do better with this animation. So with a few adjustments here, I could grab these steps, drag the content out, and sort of offset it. So we get this stepped effect coming in where the close button in the background pop in first, and then each cell will pop in underneath it. Like that, just step this off as we're going. And I'm just going to freehand this. Someone with actual graphic design and animation background would do something much better. But even someone with limited capabilities like myself from a design perspective can come up and create something that's pretty neat. And stepping through this, the effect is pretty good. Happy with that. So I will go ahead and use this animation. So I'll close this down, back out of the list view here, and now we have this menu open animation. You can see the frame rate, the duration here. And I'm going to bind it up to this button. So similar to what we did before, select the button, right click, add an action, touch, animation, select our name, menu open, and then I'm going to leave everything default, but I'll set cleanup to false. And simply because I want to be able to reverse the animation and close it up after we've opened it. So hit finish. We have this touch event. Menu open. And then if I select that main menu control button, which I know is off screen, but this is the one that has the X, I can right click, add an action, touch, animation, select our open animation, and in this case, hit reverse and say I want it to start from 100%. Finish, save that, simulate. Now we have our application. We still have all of our screen transitions, but we have this nice pop-out animation. And when I click this close button, you can see here, it reverses the same way that it came in, which is pretty cool. So, the last thing that I want to do is I want to take you through and show you what it looks like to deploy this to hardware. So I've got a Renesas board sitting right next to me. And I also have a connection to it from a SSH terminal here. What I will do is, first thing, I will set up the export options. Oh, sorry, this is the simulator configurations. You can see here, I'm going to export my application. I can choose a location, which is the file system, but I will do SCP transfer. And in this case, I can say output to the user address. And if I enable my webcam, you should be able to see my hardware there. We've got the Renesas RZ G2 board, and we're running some of our demo, but we have an IP address right there. So put in the address here, 2.168.1.9. Default username for these boards when you build them is root, and I have a directory on there already, which I can show you. So if I close down the application on the webcam, you probably see it revert to the desktop. And under user/crank, I have this SCP directory and a script. So if we go into SCP, I've got some content I've been playing around with before, so I'll get rid of that. There we go. Empty directory. And we can go ahead, deploy that here. /user/crank/scp, and apply. And I'll go ahead and run the SCP deploy. You see it's sort of working along in the background. Content was exported. We also have an option to launch it after the fact, where you can have a script on the board and call that. But for the curious among you, I figured I'd just launch it from here so I can sort of just quickly show you what's happening in the script. And also under SCP, you can see I've got the application content there. So if I quickly cat the storyboard launch script, not very complex at all. We have it set up where it might kill any previous running instances of storyboard. We export a runtime directory. So this is where all the binaries and libraries live. So this is the compiled version for Linux on the RZ-G2E platform, and this is using OpenGL and Wayland, and will run across the RZ-G2 range. There's also a software render option. If you wanted to use a version that maybe doesn't have OpenGL, or you wanted to use OpenGL for something else, that's available. And then we're simply passing in some options here, where the binary is. We want to run it in full screen. And I have also exposed a TCP port if I wanted to inject events to it from it remotely. And all I need to do then is execute the script, storyboard launch, SCP, and then the file that we exported. So you can see there, thermostat.gap. If I run that, we have the application. We have the application running on the board there, and I was running at an 800 by 480 resolution. This displays that 1280 by 800. But again, you can see here I've got my animations all set up. I also have my pop-out menu there, and it closes up. All of our buttons are still hooked up as well. So that's a quick tour of what it is to export storyboard and run it on embedded hardware. And I hope you guys found this interesting, and certainly hope you guys want to play around with it, download a free trial. So check out our website, lots of references for getting started. And then after you've built up some simple animations and behavior, next steps, like how do you connect it to your core application code? How do you send events? So custom content, maybe you might want to update your temperature right there from a real temperature sensor. So lots of information available to you, and really look forward to hearing about what you guys are building and engaging with many of you. So thank you very much for your time. I'll hand it back over to Scott, and should be good for some Q&A.
Perfect. Thanks, Nick. So just before we kind of jump into the Q&A section and wrap things up, I just wanted to kind of just give you some key takeaways from everything we discussed today. Definitely for your next embedded project when it's coming up, definitely, it's a good opportunity for you to leverage Renesas's RZ G2L series, which is a general purpose MPU. It offers significant processing power, but more importantly, a wide range of interfaces that enable you to address not only your current needs for the product, but any future needs that you may have as it comes up, really allowing you to kind of, again, really future-proof the device that you're creating for your market. I can't stress it enough. Definitely, it's not a matter of if, it's a matter of when design changes are going to occur. So definitely iteration is an essential part of the GUI application development workflow, and especially for creating those optimal end user experiences. Because as we discussed, your user interface or your user experience really defines your product and helps it stand out from the sea of products that you may be up against in your competitive market. And so definitely leveraging storyboards, rapid design, iteration, and re-import technology really allows you to make those changes to your GUI application at any point in your current development workflow, as well as moving forward. So when you want to kind of maybe give your product a facelift or a new revision. But more importantly is that if you haven't played around with it already today, we do offer a free 30-day full feature trial that can be accessed from our website at cranksoftware.com/free trial. Like I said, there's no restrictions as what you can do with it. We have a plethora of getting started video tutorials to really help you learn the product, as well as demo images for Renesas hardware that if you're looking to kind of kick the tires on the graphical performance of it, you can easily get a ready-made application that you could easily download and put onto the hardware. So that way you can really kind of put it through the paces and determine whether or not it is the hardware that's right for your embedded product. So with that being said, let's kind of take a look at the questions that you have right now. All right, so the first one up I think is for you, TJ. So when is the RZ G2L, when will it be available for sampling, but more importantly, when will it be available for production?
Okay, Scott, no problem. So the G2L has been sampling since about February or March of this year, and it's going very well. And we will be entering production in October, just as planned. So October production for the G2L, and the LC will follow a little bit after that, maybe a couple of months after that.
That's great. That's great news. The next one, I think I think I can handle it, is do I need to use design tools like Photoshop to build an HMI using Storyboard? And the answer to your question is no. If you have the individual assets, the images, fonts, and stuff like that, you can easily import those all into a workspace and start creating your GUI application that way. We just have a tendency to talk about things like Photoshop or Sketch because, if what we find is that a lot of companies that are really kind of UI UX design focused, that they're using design tools such as Sketch and Photoshop to really kind of create that design look, touch, and feel. And so we like to try to work with as many as possible and all the main tools that are being used. So that way, really making it easier and more streamlined for you to take that designer's vision and import it into the tool instead of having to recreate it manually using code. Next up is, can I achieve 60 frames per second or greater with Storyboard? Nick, I think you touched upon that at one point. I could definitely kind of start things off and if you want to pipe in any additional color commentary. The answer to that question is yes. Yes, you can. But as Nick mentioned, is that we kind of, because we have that model view kind of architecture, you don't always need to achieve that to get that fluid movement. And the reason that is that what Storyboard has a tendency to do, or doesn't tendency to do, but what Storyboard does is it takes a look at what is changing. So if you think about, say, from the home control panel that Nick was playing with, and maybe it's just you're in the thermostat section and you're going up or down. If only that number needs to change on that screen, well, there's no point in refreshing the entire screen. So we will only refresh what needs to change and how many frames that is. So, you don't always maybe record 60 frames per second or greater when you only need to change 1 or 2 frames. Nick, is there anything else you want to add to that?
Yeah, I think it's a great overview. Really, it's all about the context, right? So as you mentioned in your scenario, changing a time clock or a text field, something that's sort of a quick instant change. Well, that might be 1 or 2 frames, but if you were to look at that over the context of a second, then the actual frame rate number would be 1 or 2 frames per second, and that makes sense when you think of it that way. But from a rendering perspective, you would hit anything faster than 16 milliseconds is going to give you that 60 frames per second. So your redraw time is likely a couple of milliseconds, so very, very quick, and no issues there. In the context of an animation that I did, like you saw, where I set the frame rate to be 60, then the animation code, which handles moving all the content around, handling the updates for that, is going to target 60 frames or whatever you set it at. So, a long-winded version of yes, you certainly can. And, at the same time, we're going to be as efficient as possible and reduce as many CPU cycles and resource constraints while doing that.
Perfect. And I have another one for you too. What is the minimum memory requirements for a Storyboard application?
Yeah, absolutely. And the real answer is a little unsatisfying in terms of it depends, because it absolutely depends on what you're building and how you're building it. So what is minimum for a microprocessor might be different than what's minimum for an MCU application. So also how your content is stored, whether it's stored in Flash or off of a file system, SD card or something like that. So there's a lot of factors that impact that, but at its core, there is a requirement for frame buffer memory, and this is something that is completely agnostic of any graphics framework, is you need to have a frame buffer for the display. So that's pretty simple in terms of the resolution of your display and the color depth, so you can do some math to figure that out, whether you have 1 or 2 buffers. Then from a core engine footprint, you can run Storyboard with a minimal engine configuration. In we target some of the MCU systems that might only have 512K available to them, where there's a frame buffer in that memory and the core Storyboard engine. And we've seen the core footprint running in around 150K. But again, that's, you know, full transparency. You can take plugins and capabilities out. So, you know, things like there would be no Lua scripting. You'd be using C callbacks. There, you might be pulling out animated screen transitions, since those can require a off-screen blending buffer, things like that. But you know, it really depends, since those processors might be the wearable solutions. And if you think of sort of a wristband that's only, you know, showing you, you know, the date and time, and maybe your heart rate every second or something like that, then you know, it's a little bit more simplistic than a full-blown think of an automotive application where you've got album art for media, driver alerts, map integration, all of that stuff. So I know I sort of took a long time to answer that, but you know, we can fit in very, very tight spaces, and you know, scale down into those spots. We were always an embedded first solution, and then we pride ourselves on being able to scale up and target the larger processors and accelerators like OpenGL, and even some of the 2D accelerators that are available as well.
Perfect. Thanks, Nick. That seems to be all the questions we have today. So I want to take the opportunity to thank everybody for coming out today and taking time out of your busy schedules to come listen to us talk about the RZ-G2 series, in particular the G2L, as well as Storyboard, and how both can really help you really future-proof your next embedded product that you create. Thanks a lot, and have yourself a good day.
Thank you.
Thank you very much.